Welcome back. This time this is a demonstration of the Rnp Zulu GNSS approach to runway 29 in Proserpine, specifically using the LNav Vnav decision altitude. We're just holding south of Proserpine, and we'll just use this opportunity to once again just go through some of the theoretical components before we begin the approach. The Rnp Zulu, or the Rnp GNSS approach, is essentially an instrument approach with no ground-based navigation aids. This is exclusively using GPS. The approach with vertical guidance, or APV, barometric Vnav approval, is used in conjunction with the Rnp Apch Lnav approval, and this allows the use of the Rnp Apch Lnav Vnav procedures. The minima on an Rnp Apch Lnav Vnav is a decision altitude and not a minimum descent altitude. You can see that at the bottom left of the chart, that DA 430 compared to MDA 520 or MDA 620 if we were just using LNav. Therefore, the use of the company 50 feet addition to the MDA is not required for an LNav Vnav approach. The vertical path construction. Approaches must be selected from an approved navigation database, and modification of the instrument approach is not permitted. The procedures require glide path angle to be checked on the CDU legs page, and we'll do that shortly. For Rnp Apch Lnav Vnav approaches, Vnav shall be engaged by the final approach fix, but it should be used from the initial approach fix or the initial fix for an additional level of safety. On our procedure, we will be entering via Proserpine Echo Charlie to the south. As you'll see above there, IAF, the initial approach fix. You will also see at Proserpine November Echo, or Echo India, sorry, the initial fix, and at Echo Foxtrot, you will see that is the final approach fix as designated on the approach profile. The use of the barometric Vnav will allow the use of a lower minima. It's important, again, that Vnav be selected by the final approach fix. If Vnav is unable to be selected by the final approach fix, then the approach must be reverted to a normal Rnp Apch Lnav, or a go-around must be conducted. Just going to show you an image. This is the temperature effects on a Vnav path. The Vnav path coincides with the published angle only when the temperature is ISA standard, or 15 degrees. It will be steeper in warmer conditions or shallower in colder conditions, as the image demonstrates. If we go back to our approach chart, you will see in the box in the center, for LNav Vnav, the requirements are that we have the local QNH and the temperature is required. The procedure temperature range for this approach ranges from 0 degrees Celsius to 53 degrees Celsius. At some airports, however, this can vary and should be checked prior to the approach. What happens if we set a wrong QNH? This could have significant consequences. This image shows that the wrong path will be flown with the wrong QNH. It will be parallel to the correct path, but simply offset by the QNA induced error. There will be no indications on the flight deck, and QNA QNH cross checks at the transition and during the conduct of the approach checklist is good, and when use of the visual situation display or the VSD when available to assist with detecting incorrect QNH is also appropriate. As you will see, if we have a QNH set low incorrectly, we will overshoot, and more importantly, if we have an incorrect QNH set high, then we will end up short of the runway. As mentioned, the VSD in this image shows that the airport runway is depicted below the terrain with an incorrect QNH. This is a good tool to use. For reference purposes, you will see this approach into Albury does not have LNav Vnav minima. This is the older Rnav Zulu GNSS, just with straight actual aero and forecast terminal MDAs. This is the old charts. You'll see most of the new charts now have moved to the LNav Vnav as straight in landing minima. It's important to note that if we were flying just an LNav approach like the one into Albury, that the vertical information is for advisory only. So you will see even on this chart, because LNav approach only is an option, that at Echo India there's an altitude of 3450, at Echo Foxtrot 1860. These are advisory information only. Obstacle clearance does not take into account temperature effects, barometric altimeter accuracy, flight technical error, etc. The obstacle clearance is based on the pilot not flying below the published minimum altitudes on the charts. In the case of the LNav Vnav approach, however, vertical guidance information is provided. The published glide path takes into account temperature effects, barometric altimeter accuracy, and flight technical error, etc. The approach does not rely on the published minimum altitudes. As most RMP approaches LNav Vnav are published in conjunction with an RMP approach LNav, minimum altitudes may be depicted, but technically these do not apply on the RMP approach LNav Vnav, which is the one we're going to fly today. Lastly, the glide path angle must be depicted. You will see from Proserpine Echo Foxtrot to runway 29, it's 3 degrees. We will recheck that in the CDU shortly. This image shows that from the final approach fix through to the missed approach point, the vertical RMP must be 125 feet. It's important also in the 737 to monitor our navigation performance scale indicator just here. This will show us if we have a cross-track error. Now, let's talk about the specific procedures for the approach. These need to be checked before every approach. We need to ensure that we have 2 ADIRUs in nav, which we have. We need to have 1 CDU. We need to have 2 primary flight displays, 1 GNSS receiver, 1 flight director, 1 navigation display, 1 FMC, 1 radio altimeter, and 2 navigation performance scales. In preparation, we check the minimum equipment serviceability, which we have done, and we check and set the approach RMP to 0.3. So we do that by going to Program and going to page 4. RMP approach is already preset to 0.3. The next thing we look at is to check and set approach vertical navigation performance to 125 feet. In this case, it is set to 400 feet, so we will adjust that to 125. So we have vertical RMP 125. So currently the RMP, because we haven't commenced the approach, is set at 1. That'll transition to 0.3 shortly. And the actual is 0.06, and again we've set 125, and the actual is 80 feet. Just going to start taking us out of the hold, and we'll proceed direct Echo Charlie to commence the approach. Now, you'll see this message, drag required after Echo Charlie. That's because the aircraft wants to start slowing down before. On the approach chart, there is a restriction of 210 knots for this procedure. As a consequence, that's been built in. What we can do is go 210 knots, B for below, and now we won't get that message in the scratch pad any longer. The aircraft will start to reduce below 210 knots before Echo Charlie. Back to our list, we need to check and select that the DME updating is off. We're not using that feature. That's under route. No, sorry, that's under position. Nav status on page 3. And then our nav options number 2, so we're going to put DME update off. You can see it's a little confusing. We set both MCP course selectors to the final approach track. The final approach track in this instance is 286. We set the primary flight display barrow minimums to the decision altitude. On this procedure, it is 430 feet, and we don't need to add 50. That has been set. We need to check the actual aerodrome QNH from an approved source, which we have, and also we need to check the reported temperature is within the limits, which I have checked, and it is. We have selected the approach by name from the current navigation database, and now we will check the tracks, distances, altitude, speed constraints, flyover, flyby waypoints, and that they agree with the charter procedure. As we do that, we will check the vertical path angle as well, and then we will brief the approach. So our approach has from Echo Charlie we have a heading of 356 for 5 miles, which confirms that. Then we have from Echo India to Echo Fox 286 and 5 miles, which checks. And then from Echo Fox through to the runway, we have 5.5 miles on 286, which is checked. Then we fly to Echo Hotel, which is 2.5 miles, and then we turn right on a heading of 080 and climb to 5,100 in the case of a missed approach. Those check. Also, we check that it is a 3-degree glide path that matches the figure on the chart, and that matches the figure in the box. Okay, so we're ready now to commence the approach. As we continue our tracking towards Echo Charlie, let's just briefly discuss the conduct of the approach. So the autopilot should be engaged, and we should monitor our cross-track error from the initial approach fix. we should have FMC legs page and VSD by the initial approach fix. So we've got legs page and VSD set. We should double check the RMP changes to 0.3 by the final approach fix and check that the RMP is at 125 feet by the final approach fix. Approaching the initial approach fix, we can reset the cleared altitude for the approach and compliance with any altitude restrictions and compliance with any altitude restriction is assured. Then we can set the MCP to the decision alt or the nearest 100 feet setting above. So in this case, we'll assume that we are cleared for the approach, and we can reset the altitude to 500 feet. And as our VNav path starts to come down, we'll engage VNav. Once we are 300 feet below the missed approach altitude, which is 5,100, we can reset the MCP to the missed approach altitude. If after the initial approach fix we have a position uncertainty, a cross-track alert, or unable to engage or re-engage LNAV and VNav in IMC, we must conduct a missed approach. After the final approach fix in a missed approach, we should also rather conduct a missed approach in IMC if we receive a vertical deviation alert amber. It is noted, however, that vertical deviation can momentarily exceed above the vertical path due to aircraft configuration changes, and a missed approach is not required in this instance. Okay, so let's do it. FMC speed.
Check.
VNav path.
Check.
So we're approaching Echo Charlie at 5,100 and our speed has now started to reduce. Flaps 1.
Flaps 1, 5,000.
So we now have 0.30 RMP and a vertical RMP at 125. Our actual is 80 and our actual is 0.06. Flaps 5.
Flaps 5.
Drag required. Now a reminder, once we're 300 feet below our missed approach altitude, we can set our missed approach altitude. Sometimes PMDG is a little buggy, so the best thing to do is just wind it up as quick as you can past our present altitude, and it should work fine.
1000 to level.
So now we've set 50, 100 in case of a missed approach. The aircraft will keep descending, however. Knot tail into present. Gear down. Gear down.
Gear down.
Flaps 15.
Flaps 15.
The Vnav will reduce the speed as well, in line with our approach, with our flap speed. So as you can see, it's bugged to 15 right now. Flaps 25.
Flaps 25.
Comes the typical rain. Flaps 40. Flaps 40.
Flaps 40. Final approach fixed, height checked, missed approach altitude set.
So now we're looking good. Landing checklist.
Landing checklist. Engine start switches.
Continuous.
Speed brake.
Armed.
Landing gear.
Down.
Flaps.
Flaps 40 green light.
Landing checklist complete.
So at this point, we are now keeping an eye obviously on any cross-track limit, but also because we're inside the final approach fix, we want to make sure that we're within 125 feet of our vertical RMP. Let's hope we see the runway by 430 feet, otherwise we'll be going around. One thing I did forget to mention is, as we will be landing manually, we must disconnect the auto throttle.
Runway. Not stable.
I'm sure we are. Missed approach altitude is set. And that is because if we don't do that as we touch down, it'll try to increase speed, and that won't do anyone any favours. So it's an uncontrolled airport, we're clear to land, all the lights are on. Set wipers off.
Wipers going off.
My aeroplane.
Check. speed brake up, reverses normal, auto brake disarmed, 60 knots.
Manual braking. And we made it. Again, practice makes perfect. We'll look at the Rnp approaches next time.
Master